Today we're going to be talking about some of the infrastructure changes that we've been working on over the last year. I'm going to give a brief overview of what we're going to talk about today. We're going to talk about what are the challenges that we're trying to solve with new infrastructure. We're going to talk about some of those infrastructure changes. I'm going to go over a web API, which is REST-based. We're going to talk about what that is. I'm going to talk about SPAs, or single-page application, what those are and why we might need them. I'm going to talk about AngularJS, which is a single-page application framework. We're going to piece it all together, and then I'm going to run through a demonstration and some code. So first off, what is it that we're trying to solve? So if you were in one of the presentations this morning, we saw some information about how IMIS is moving more towards a cloud or a hosted solution. We're getting more into software as a service. So some benefits of that would be you have a hosted high availability API. It's always on, takes some of the guesswork out of trying to host a large-scale internet application. You get enhanced hosting with that and monitoring. That's overall going to reduce your IT costs. But one of the side effects of that is that there's no direct access to the underlying infrastructure, so no access to the file system or IIS. Traditionally, access to the file system and IIS is how we've provided extensibility options in IMIS. Some benefits of not having binary uploads is you have a little bit of safer hosting. The less third-party code, the better. One of the benefits of that, however, is we offload some of that server-side processing. So the browser is actually doing some of the processing to render those widgets, which ultimately will end up faster. It also means your server is going to take on a lower memory footprint. That's going to be better overall because fewer or less memory consumption on a server means that you have fewer resources that can provide to more consumers. So we're not going to take away IMIS extensibility options, but we do need to create new avenues to achieve the same thing. So our options for that right now is we have a new REST API layer in our software as a service, and that can allow for new options with single-page applications built with HTML5 and JavaScript. Some other infrastructural changes not related to that is that we've retired our Windows services. So the publisher service and the workflow service have been retired. Those used to run in Windows. Now they will be run as a web application in the IIS application stack. This is called ASI Scheduler. You might have heard a little bit about that over the week. It's an auto-started, always-on web application. And it runs off of a push model rather than a pull model. So the old Windows services would pull for changes every 5 or 10 seconds. Aside from being kind of slow, that also chewed up a lot of resources. So you have processes that are constantly querying the database. You have memory to manage those processes. Overall, a push model where the database pushes its changes to the service results in about a 75% decrease in that network traffic and memory consumption and database querying. Another benefit is that published content is now instantly available. We're not polling the database anymore. So once you click publish on an event or a person or whatever it is that you need to publish, it's instantly available as soon as you refresh the browser. Our web API that is REST-based is also hosted out of the ASI Scheduler. So we now have a web API that you can access SOA through, and it is REST-based. So what is a REST API? Well, REST stands for Representational State Transfer. What does that actually mean? It means that we let the protocol, HTTP, represent its state on how we want to achieve our data transfer. So you might have heard of HTTP verbs, commonly get and post. There's some other ones, put, delete, patch, etc. It basically says that if we're doing an HTTP get, that we know we want to get some data. Likewise, if we post, we know we want to write some data. So I have an example of just a regular web API versus a REST web API. On the left here we have the web API. And this might be a URL that you might interface to get some data out of a web API. So on the left we see that we have some redundant data. We're already doing an HTTP GET on both of these web APIs. But the web API that's not REST-based has a little bit too much information. We say we want to go to a product or a product controller. We say we want to get the product, and we specify the ID we want to get. So the REST API is basically just taking some of that redundant information out. Likewise for post, if I want to add, edit, or save a product, well, I have to look at someone's documentation to figure out what they named their method to edit or save that product. Again, it's much more simple with the REST API. We just know that if we post, we want to write or save. So it's almost self-documenting. You have to know a lot less about a REST-based API, which is why the industry really prefers them. They also have, web APIs in general are going to have a far more wide reach than, say, like a WCF or a request-based API. So that means any browser or any device, a lot of devices have browsers these days, can access them. So that means we have a far reach that we can access this data from. .NET has also been pushing towards REST with their web API models, both 1 and 2, both promote REST out of the box. And although JSON is not specific to REST, you can have other data formats. Traditionally, JSON goes with REST APIs, and that's a smaller footprint, which makes it a good candidate for mobile. So we have less data being transferred over the wire, and we don't have to send any data packets to request data. We just request it from a URL. So traditionally, we've accessed IMIS APIs through SOAP and WCF. So our SOA has been WCF for the last several years. WCF was really a configuration over convention. And what I mean by that is that, these HTTP verbs, HTTP has been around forever. So WCF came out and said, well, that's probably not enough to really create this fully featured, rich API. People want more options. They want to build SOAP envelopes that have tons of extra pieces of information in them. It turns out that really wasn't the case. Sometimes simple is better. So SOAP, over the last couple of years, did attempt to support REST using attributes, but at that point it was a little bit too little, too late. A bit like putting lipstick on a pig at that point. So that versus a REST API gets back to those conventions. It gets back to using HTTP verbs to define how you want to interact with your API. And so REST is an architectural style. It's not a standard. There's not a set of rules out there. You might hear people describe this is a RESTful API. Truthfully, a good API will be a REST API, but not only a REST API. It might have some of those verbs for those more complicated actions that you want to interact with. So here I have an example. It might be kind of hard to read, but what I have up here on the top is a REST API call to get an IMIS party. So all we're doing is we're just sending a URL. We're just doing an HTTP request to get this URL. Down at the bottom is the older traditional way to construct a SOAP envelope to get an IMIS party. Immediately right off the bat, you can see that one is much easier than the other. This SOAP envelope is complicated. It's hard to read. You sort of have to stare at this for a while, even if you know SOAP, to figure out what exactly this envelope is trying to request. And it's also just more data over the wire. So here I have a screenshot of just an interaction with a Chrome app that you can interact with APIs with. And up at the top here, I've got a similar URL that I'm requesting the data. And down here at the bottom, it's that data that we're getting back. So it's much more simple than XML. It's much smaller. Even if you're not a programmer, you could sort of look at this and see that it's a data object, and you can see that it's much more easy to read. And again, it's much smaller, so less data going over the wire means fewer resources can provide to more consumers. So here's a similar example on how to do that with JavaScript. So I've got just a simple function here that is building a URL dynamically and then doing a simple jQuery get to get that data. And so this is the output of that data. It's a JSON object. If we were to parse this in JavaScript, we would then have a JavaScript object that we could do other code operations on. So we implemented REST in IMIS in our ASI schedule, so it's part of the application stack. And we used ASP.NET Web API 2 to build it. And so the result of that is that we now have new extensibility options for HTML and JavaScript clients. We can create client-side SPAs and HTML5 content items. So what is a SPA? Well, you might have walked by a couple on the way here, but we're not talking about that kind of SPA. We're talking about single-page applications. So what is a single-page application? It's a lot like it sounds. It's a single page that loads all the code necessary to run some features or all of the features of an application. So it can be kind of a misnomer sometimes. You may not want one single page to flesh out your entire application. That would be a little bit too complicated. But a single page application can do many things. So it gets back to having an application that looks less like a website and more like a desktop application in your browser. So why would we choose single page applications? Why are they a good thing? Well, HTML, JavaScript, CSS, that's the least common denominator between any device that has a browser. So Google has Android, Microsoft has Windows and Windows-based phones and tablets. Apple, of course, has OS X and iOS devices. They all have browsers on them. And these browsers all can read HTML, JavaScript. So also, web browsers have been getting better over the last couple of years. They are now able to piggyback off of graphics processors and use hardware acceleration. Mobile phones now have hardware acceleration. They also have dual and sometimes quad-core processors, so that makes them much better suited to taking some of that processing away from the server and onto the client. Browsers have also developed faster JavaScript engines with this sort of development in mind. Google and Microsoft have both redesigned how their browsers process JavaScript to make them more optimized and better at handling manipulations to the DOM. So a single-page application that you might all be familiar with is Gmail or really any webmail client, Outlook or Hotmail or anything, is going to be a single-page application. What that really means is as you're clicking through your email or going from your sent mail to your inbox or receiving a mail, you don't have any page lifecycle. You don't have page refreshes. So when you click on something, it's instantly available, and you also can have things pushed from the server to the client without any user interaction. So how did the industry go from where it started in HTML markup to single-page applications? Well, we first started with static page, just hypertext HTML markup that had some content on it that was served over the wire. Then we went to a full page load with data fetched from the server. So that's more when you have server-side processing that renders a template based on some server-side code that builds the markup that then gets sent to the browser. So you're basically just rendering and sending down markup. That has some consequences. It was revolutionary at the time, but it does cause the user to have interrupted, we all have interrupted experiences. We all know when you click on a web page or an older web page, it sort of refreshes and takes a while to load and the screen might flash. So over the last, about 8 years or so, client-side JavaScript has been trending upwards to create partial page refreshes. So you can maybe contact the server and say, yeah, give me part of this page so I can update. So things like lazy loaded images or lazy scrolling, where you scroll down and only things that are loaded as you see them appear on the page. MVC frameworks have been gaining a lot of popularity over the last 10 years, started with sort of Ruby on Rails, and now Microsoft has also adopted MVC frameworks that do a lot of scaffolding. These aren't specific to client-side frameworks, but they are geared towards them. They make them very easy to make that transition. And then lastly, over the last 2 or 3 years, there's been a huge shift in web development towards client-side frameworks that are geared towards generating single-page applications. So that means you have a template that's sort of hosted a server-side, you have markup that you provide, and then the browser loads the view, but there's separation between the view and the server. So the view comes down as markup, and then data is loaded into it as the user requests that behavior. So some best practices when you're constructing a single-page application is you want to use a framework, and that's really true of any software development. Frameworks address common architecture problems, design concerns. want to be chosen for you because you want to choose a common framework as a language that you speak to other developers with. It's much harder to roll your own frameworks and get all these things like intelligent routing, data binding, dependency injection, etc. if you try and build it yourself. So we use .NET. A client-side framework is just as important. So what are some client-side frameworks? Well, here are three of the more popular ones. We have Angular, Knockout, and Durandal rendered on a graph generated by Google Trends. And we see that about 2011, these things really started popping up, but we see that AngularJS in particular, which was built as a Google side product, it's actually not a Google product though, has really eclipsed all of them. It has risen sharply in the last year or so, and it really shows no sign of slowing down. Now, why is that? Well, it's because AngularJS is a complete framework. It's not just a library like some of these other client-side frameworks that you might have heard of. It's not like jQuery. jQuery is more of a querying language. It's very powerful, and you can do a lot with it. And you could even build a single-page application with jQuery, but you're not going to have a robust framework with all these things to choose from. So Angular is really the .NET of the client-side world at this point. So here's an illustration of how an Angular JavaScript app will be constructed. It's a lot, again, I'm going to use .NET as an example. It's a lot like a .NET application where you have sort of an application base, you have configuration. It is based on the MVC or MVVM model, so you have routes. And when a browser requests a route, or a URL, that gets resolved to a controller and a view. Between the controller and a view, there's a concept called scope, which is basically a way for the browser to share data between the controller and a view, and it is a two-way binding. So anytime a controller updates some data or the browser updates some data, its partner is updated automatically. And lastly, we have directives in Angular, which are a bit like an ASP.NET control or a Bootstrap widget. This is where you write sort of custom markup that has code that controls it. And you also have a concept called factory. Now, factory is a software design principle. It's not something unique to Angular, but that's how you create sort of your services layers and inject them in places or your repositories. What does that give you? That gives you testable code. One concern lots of developers have about going to client-side frameworks with JavaScript is that you might lose some of your testability. Well, Angular brings that back. It was written with testability in mind. So how does this all fit together? Well, we talked about the ASI scheduler, which is our provider of REST API, which is consumable from JavaScript. And within IMIS, we have a content HTML dynamic content item. So what that means is now that we have a client-side single-page application, which can be constructed out of nothing but HTML and JavaScript, no compiled binaries, it means out of the box today, with this API, we can create single-page applications or dynamic content items using markup and client-side code. So I'm going to demonstrate what that might look like right now. So here I am in IMIS, and I have one piece of content on the screen. And let me scroll down a little bit. And I'm going to turn Surf to Edit on and take a look at what this content looks like. So you can see that we don't have anything in the design. This is not sort of an HTML widget, but what we do have is some HTML or actually script references that are loaded into the application. So up top here I have some Angular libraries, so that's how I access this framework. And here I have some of my own client-side code. And in this example, I've hosted this locally. But these could come from anywhere on the web. So you could have this referenced on your own website. So if you are in the cloud, you don't necessarily need access to the file system to achieve the same thing. Or we could provide an avenue to upload these scripts through the IMIS interface, much like you do a document, and you will have an application. So we have a couple different things here. We have a module defined, which is sort of the application framework. We have a repository, which is my services layer. And then we have some controllers, which if you're familiar with MVC, you know what controllers do. And then the only actual markup on this page is just basically telling Angular, hey, this is where I want to insert my client-side application. So what does this application do? Well, I mentioned single-page applications typically do more than one thing. Turn Surf to Edit off. And in this case, I have a nav bar that does only two things. So if we click on one of them, we see that I can search for parties. If I click on products, likewise. So if I go here and search for parties, I'll just search for a last name. I get a response back almost instantaneously, and if you notice, there was no page refresh. That was very quick. If I start clicking on these search results, I can have an edit form built right in. I can move around, again, no screen refresh. I'll just click very quickly here to show you how quick interacting with an API like this with client-side code can be. And it works both ways. I've got Chris Baker here. If I change his name to Tom and I submit this, I'll do a search again. I got my results back. Again, I've done all this. I've written back to the database. I've got Tom changed down here, and there's been no page refresh whatsoever. So if we check out Tom Baker in IMAS proper here, I'll search for him in the actual application. You see that his name has been changed. Still Chris Baker, but his name is now Tom. I can view his profile. We see that change history is intact. So we are, in fact, interacting with the IMAS database. We're just doing it in a new way. Instead of from compiled binaries, we're doing it from JavaScript and an API. So same is true of products. So single page applications, I mentioned they do more than one thing. So this is all within the same content HTML piece of content and just a few pieces of markup and code. So if I search for certification, I get some search results here. I'll click through them. Once again, quite quick, no screen refresh. I'll go ahead and add that to the cart. We should see, once the processing is done, we should see, there we go. A little bit slow, but if we go and look at the cart, again, it's an IMAS proper. It's all gone through SOA. And there we have our certification handbook that we've added. So what's actually going on here under the hood? So take a look at my client-side code here. I just have some references to some local files. Like I said before, these files could actually be hosted anywhere on the internet. And this application is entirely composed of JavaScript and HTML files. So it has some structure to it, like an application should. It's got a service layer I mentioned before, this API repository. It's got my actual module. And it's got some controllers which control each one of my functions. So party controlled that party widget I had, and product likewise. So if we actually want to take a look at this code and what it's doing, I'm going to bring up Chrome Developer Tools. Let's see if I can make that look a little nicer. And I'm going to go ahead and search for a product or a list of products, so search result. And we can see that we've broken into some JavaScript code. This accesses my services layer. And I'm going to go ahead and F8 through this so I can actually get some data. And now I've got some, where did I break to? Okay, we're in the services layer. We'll just go ahead and skip that part. We're back to my controller, and now we are mapping our data result from the API to our controller, and that gets bound to the view. And so if I take a look at Fiddler, which is just a way to inspect network traffic here, we'll see that up here we have all these calls. I'm not really going to go into too much detail here, but I just want to highlight this call here was the call we made to search for those products. So we have a nicely formed JSON representation of one of our data contracts. So if you're familiar with our data contracts in SOA, you're immediately going to be familiar with how these JSON objects are going to come back from SOA. So this is a collection of items that met the criteria that I asked for out of the API. So that's great for a single page application, but what if you wanted to have an iPart sort of that extends current functionality? What if you just wanted to create a small widget? Well, I'm going to hop over to one I've created earlier, and I'm going to look at our annual conference event. And here at the top here, we see a new widget that I've added, and it's basically just a small single-page application built from Angular, but it really is what we all know as an iPart. So what this does is it goes out and it does a query, and it looks for the colleagues of the user, and it finds out which ones are already attending this conference. So if we scroll through that, we're getting just data calls one at a time to fetch someone's image, but it's very seamless. It's all coming down the API because the client side is doing all this processor instead of this, all the processing instead of the server. So this behaves just like an iPart. Since it's a content HTML widget, say we don't like it up at the top there, we want to move it, we can because it behaves just like an iPart. So if I grab this content HTML that I have, I've named it My Colleagues. I'll find a better spot for it. Let's kind of zoom out so I can get there. Well, that's going to be difficult on this screen resolution, but you guys get the idea. I could drop this anywhere on the page just like you can with any iPart. And if I were to save and publish that, we would have the content would be moved just like any compiled binary that you guys might upload today. So what questions can I answer about this process? Right now it only has the content configuration options for content HTML. The configuration options that you would do, you would configure in your own code. There may be other ways to add these iParts to a page that would give you that same configuration options that gets sort of serialized to our database. So the better answer to that is today, no, in the future, probably.
So the controllers that you have, like the product and the party, can we have our own controllers for our extended SOAs that we have?
Yes, so these are just JavaScript pieces of controllers that I've written, and they don't need to be in the application at all. They can be hosted on an external website even. So as long as those controllers have a way of having knowledge about what the URL to the IMIS application is, they can access the API and run directly from the browser. So right now we don't have a way to do that, but there are talks about how to do that. We're thinking we already allow you to upload files into our document system, so it would probably end up being much like that, or some kind of single-page application content item. We obviously are in the R&D phase for that, but we have talked about that kind of avenue. Mark?
Since we're recording this, we remember to repeat the question.
Thank you. Go ahead.
When you make an HTTP call, how do you do security? So how does it know that that JavaScript code that's being called is an authenticated user, has access to that user profile?
Good question. So the question was, how does the security work between the application and the API? And so right now it uses something called implicit browser authorization. And more or less what that means is that cookies are shared between since we have, excuse me, let me get this slide up. So since ASI Scheduler, as I mentioned, is hosted in the same IIS web application stack, we're able to share cookies between them by sharing machine keys. So essentially, anytime you log in or authenticate with the application, it has a way of sharing that same forms authentication with the API. On a different server, we have been talking about other authorization models, such as token-based, but this is what we have right now for this sort of prototyping and R&D phase of this.
Can you lock it down to like member, like different roles? So could a member have one access to certain content and other roles have different content?
Good question. So the question is, can you lock it down so that you have role-based authorization? That's already available out of the box. So this API goes through SOA. So any SOA claims that you have built today or any roles that you have defined will go through this API. So if something is not authorized in IMIS in the application, the API will return an HTTP equivalent of access denied or not authorized.
And another question, are your cookie sessions encrypted or are they just raw data streams going through your cookies?
The question is, are our cookies encrypted or are they raw data streams? And I'm 99% sure they're encrypted, but I might have to get back to you on that. Go ahead. Of the API, this would be... This actually would not be released yet to V100, but it would be available probably in the next GA release for IMIS 20-100. 300s, I know that we've spoke about that. Mark will be able to field that one.
Right now, it is in the 2100, 200 code base. It won't be available publicly until the next GA version, as Mike pointed out. And we're looking to how we're going to activate this over the 2300 code base as well. If we get it there, in all likelihood, it will be available within the next GA release of that. Don't hold me to that at this point in time, because we're still working through it.
And do you anticipate this REST-based API being accessible externally, or is it again going to be locked down to?
So with the first implementation, it will likely only be available as a consumer on the same machine. But there have been many talks about creating a token-based authorization model so it can be available externally from other callers. So OAuth 2 being the one that's been thrown around the most, but we still are in the research phase of how we're going to accomplish that. Any other questions, comments, discussions? Go ahead.
So the iPads that we have, the configurations for that we have now, how is it going to be placed in the APIs?
So,
Are the feature, are we still going to have that feature, or is it just going to go on?
no, so the question is, I think our iParts, traditional iParts that are based on compiled binaries still going to be supported. And the answer to that is, well, it depends on the branch and how you're hosting specifically. So, the ability to upload compiled binaries into, say, the 100 branch, which is a cloud-only solution, that's not going to be available. So to extend that, you would want to go with an option like this. For 200, Mark, that's sort of up in the air about compiled binaries, but you'd probably likely, again, go with this kind of model for extensibility. On your self-hosted 300 solutions, that's not going anywhere anytime soon. I can tell you that the industry is more moving to this model, so I think as web development progresses along the next 5 or 10 years, more people are going to favor this model. But I think IMIS is going to support compiled binaries in your own hosted solutions, or your even the individual hosted solutions that are provided by ASI hosting for a long time.
I mean, are you guys changing your iPads and your configurations to fit into this?
We haven't yet. We still primarily consider this sort of a prototype and research and development. I know a lot of our developers are excited about this and would like to, but right now we have so much momentum with our compiled binaries. We are sticking with that until we have a more robust implementation of this.
One thing that would help set some context for this work we're leading with in the 2100, 200 code base, and We're not introducing it in 2300 for obvious reasons, because the cloud is what 2100, 200 is focused and targeted on. We are going to provide methods to extend functionality, feature set. It won't be in the traditional iPark way we compile binaries, but on the 2300 cloud, even there, your customers can avail themselves of a virtual dedicated server. So if they wanted to have that kind of a solution set or suite over there, they still be available to them. So we aren't going to just switch the light off and everything goes away. We will provide options for your customers and for you to make sure that all works.
Yes. Just concern on that. You talk about, maybe not doing it for 300. We got a lot of just business impact. We develop an iPark today, it costs $20,000. Or something to develop some custom process. They like to move in this direction. And I would think that you want to get it 300, so our teams are moving in that direction and not building new iPark binaries going to 300 that we would want to transition to that 5 future. Seems like a misstep if we don't try to get that to 300 in the next level.
We're looking for demand. We really would be. And
We demand it.
if it makes sense, we'll do that. We're not going to just turn a blind eye and make a black and white decision one or the other. We do know for a fact we are going to be going this way and the code base is 2100, 200. 300 is another beast. Because there's a lot of sunk. There's a lot of sunk cost and investment in 2300 in traditional iParks, and to the way that it makes sense for us to lay down the RESTful API over on that code base and the 300 code base, and to start making provisions for MVC-based or this type of approach that Mike has shown today. We'll enable that as well. More than likely, what you will see, rather than full-blown MVC framework show up in 300, you'll see capabilities for what Mike has demonstrated today. It's pretty straightforward to provide the RESTful API over existing SOA over there. And what he has shown you today, you can do today with the content HTML iPark, or putting Angular embedded within that. That's exactly what he's shown. So that makes sense. So those kind of things we will move forward to support. But when we start getting into much more sophisticated full MVC frameworks, then that's where we're going to have to make some decisions, whether it makes more sense to expand and blow that out over on the 2100 and 200, because that is cloud for sure, and what priorities would make us consider doing that.
Look at the financial factor, live a day, after we get to get in that cloud environment.
And Mark, just to comment on that, web forms is by no means dead yet, but it is dying. Developers are moving away from it, so having both options available is only going to improve being cost-effective development. What other questions or comments? Go ahead.
So are you saying that you're moving away from the WCF model?
So the WCF model is still available. And this is just a new way to access SOA. So the WCF model will still be supported. There's no even retirement date for it that I know of. So if you are interacting with it through C# or even through another avenue, if you're building SOAP envelopes by hand by using PHP or something else, that's still going to be supported. Right. So there would be some argument for staying with WCF if you have an extremely high output capability or application. However, that said, I would like to see where WCF outperforms the REST API. Almost in every single case, under any load that I've seen, the REST API is going to be faster because it's actually just simpler. It lets sort of the HTTP protocol tell the API what to do instead of a bunch of extra handling and processing of all those WCF attributes. And the payloads, both to request a WCF data contract and to receive one, are 10 to 20 times smaller. And that's not an exaggeration at all. I mean, it's a much smaller transmission over the wire.
Does that go away? Would that be away?
So the question is, how do we interact with SOA when SOA doesn't do the custom things that the clients need them to do? And I guess that depends on how you're working around SOA now. If you're accessing the database directly, if you're writing your own stored procedures or writing code modules that access other parts of the IMIS API, then again that would go away depending on your selection of the product. So for 100 and 200, that certainly wouldn't be an option. But for the other side, it would be an option. Now, if you're just talking about SOA not doing what you need it to do, well, you can always extend SOA. It's fully customizable, and you can write your own modules in SOA, and those modules would then become available in this API as if they were written by ASI in the first place.
But not with 100, 200.
Not with 100 and probably not with 200 either. Is that, yeah. So I don't know that there's going to be any options for extending SOA for those particular product lines. Any other questions? All right, well, thank you very much for your time.